Welcome back. All right, so how many? I'm sure. I think I asked this before. How many people have encountered the term technical debt? And it wasn't a great number of people. So, which is good because you're going to get it now. So, technical debt. I'm going to explain what it is, and I think I explained it earlier in the class. It's this sort of model we take from economics about how your project can accumulate debt. So your project can accumulate, of course, financial debt. If you spend a lot of money and you burn through it, and you don't have any money to replace it, you're burn it. You they call that a burn rate, and you don't want to have a high burn rate because you want to have, if you have funding, you want to keep your funding at a level that you can replace it. So technical debt is sort of like that, except it's not easily quantifiable. And it's also based on sort of more intrinsic things within your project. So if you start out with a project and you choose a certain programming language or a certain piece of hardware, um, that has to be, something that's supported for the long term. And if it's not supported for the long term, there's some debt built into that in terms of either having to migrate to a newer system or maintain the older system. So there are a lot of government agencies and a lot of organizations uh, that have their systems running on legacy hardware and legacy uh, programming languages. So there occasionally you'll find different municipal organizations running their scheduling software on like an old Mac, and it's like, well, they don't support the computer anymore, but they can't move because their software is just the way they want it. And it would cost them a lot to move the software or to change software. So they just keep that old solution. Does it mean that they can't do certain things? Of course it does. But it would cost them more to move it to migrate to a new system than otherwise would be the case. So this is the kind of thing, and we'll talk about different cases of technical debt as we go along. So we can think of technical debt in terms of communities. We can think of technical debt in terms of core organizations or core development teams. But it's always the same story. If we have like people who maybe weren't as experienced in developing software and they contribute something to the core development team, there's probably a higher level of technical debt in that than if you were to have it be developed by the core development team. On the other hand, the core development team might actually incur quite a bit of technical debt going into the project. So it's really, you have to kind of figure out what the sources are, and it's not something you can beat. You can't like manage zero technical debt. We'll talk about that. So the definition of technical debt is the implied cost of additional rework caused by choosing an easy or limited solution. Now, okay, so you're making decisions right now about your project, and you're saying, this is the way I want to start my project. I want to start it with using a certain programming language, using a certain technology, and I'm going to assume, or I can't really assume that it'll last forever, but that's the best I can do for right now, given my constraints on funding, given my constraints on time, given my constraints on my team and expertise that they have. So you pick a bunch of solutions now, and sometimes you pick sort of an expedient solution now, something you can just implement quickly rather than trying to spend 6 months implementing something. Now, sometimes that is fine, and sometimes it comes to hurt you later because the easy solution is not always the best one. Okay. So sometimes we pick an easy or limited solution now instead of using a better approach that would take longer. So we don't want to spend a year developing the perfect solution. We don't want perfect to be the enemy of the good enough. We want the good enough to move forward. But then there is a consequence to that, which is that you incur a certain amount of debt or you have to keep reworking that solution as you go along. And it costs you resources and it costs you time. So, normally all projects will have some technical debt inherent to them, and that's okay. But what you want to avoid is ignoring that technical debt, or you want to keep it from becoming too large or too great. So again, like I said, it's harder to quantify than financial debt, but it is there, and you can detect it in sometimes very overt ways. And so, what you want to do is you want to have it have the technical debt be manageable instead of letting it pile up over time and then having to solve it all at once. Sometimes it can sink your project, other times it can really negatively impact your project. So when ignored, debt accumulates over time, which is, there's this analogy to economics, which is the analogy of negative interest. And then if you leave things over time, they sort of compound and it becomes harder to pay off, much like a debt if you let the negative interest compound on it. And so, again, if you have a easy to implement solution, but the consequence of that is more bugs, and then eventually, if you let that kind of linger and you don't really solve that problem, you get more and more bugs until your program simply won't work because it has so many bugs in it. So I have a Technopedia article here which goes over the definition of technical debt. This term was coined by wiki creator Ward Cunningham. That's Ward Cunningham. It has its origins in extreme programming and refactoring. So, this is an activity that programmers do where they try to sort of figure out ways to optimize their work. And refactoring is where you go in and you actually rewrite the code systematically. So you have an existing code base and you just go systematically through it and rewrite it. And that sometimes the solution to paying down your technical debt, but it takes a lot of resources. It takes a lot of time and it takes a lot of labor. So it's something that, we want, I guess we could refactor things if it gets to that point. We want to avoid that. We want to make sure that things are running smoothly and we don't have to undergo these sort of major reconstructive surgeries to our project. If you're familiar with Scrum, this is a common topic in Scrum. I have an article from scrum.org where they talk about who's responsible for technical debt, which is of course the other issue with technical debt. It's not just that it can hurt your project, that it can keep your project from flourishing. It's that if you do have technical debt, and you might have a manageable amount of technical debt, but it might also be that no one wants to take care of it, right? No one wants to take out the garbage. No one wants to do the maintenance. No one wants to mop the floor, that sort of thing. So if no one wants to do that, and everyone thinks it's everyone else's responsibility, those things simply don't get done. And these this sort of debt accumulates over time, and then you run into problems. So this is kind of technical debt summarized in three memes. So we have the distracted boyfriend meme where you have developers as the boyfriend, the bug fixes and refactoring as the sort of the solution to technical debt. And then the boyfriend is distracted by new features that they could be building. So, instead of building new features, you should be fixing the features that you have, fixing the bugs, trying to perfect the code. But instead, people get distracted by new features. And that's oftentimes a case where you have like maybe five features you start out with. And instead of perfecting those, you move on to build more features. And you keep doing this until you get 20 features that are really buggy instead of five features that are really perfected or optimized. And so that's one way you can have technical debt. And it's just a matter, it's not even really distraction. Sometimes people just think that more features are better and they ignore the simple fact that you have to maintain whatever you build in your project. If you have more complexity, you have to manage that complexity. And if you can't manage that complexity, then you just have to try to constrain the scope of your project. The second meme is where you have a product manager and they're reaching out for a new feature. Like in the first meme, they're always receptive to new things, new shiny objects, but then technical debt is this monster. It's pulling them back away from that new feature. And it means, basically they can't implement new features until they pay down their technical debt. Sometimes it's a situation where you want to put in new features, but the environment is such that it won't let you do that. It's just going to cost you a lot. And the specific case I'm thinking of is like when Microsoft has built some of its operating systems, and they've tried to do really groundbreaking things, but the way that they've implemented it because of the technical debt of their Windows platform is such that it ends up coming out not well, like a half baked cake. I'm thinking of Windows 8 specifically, but anyways, you can think of other examples of that where it's just you try to do new things, but because you're the the platform you're working from is so bad and has so much technical debt, it's riddled with technical debt that you can't do those new things. The third meme is, of course, Fry from Futurama. Not sure if refactoring made code more understandable, or I just understand the code better because I spent hours in it. So sometimes, you do the due diligence. You do something like refactor. And one of the things in refactoring you do is to try to make the code more optimal. Sometimes you try to make it more understandable to your team. So you might spend time annotating the code and, or fixing variable names or whatever. And then but sometimes you're delusional in that, and you just do things that you understand, but your team doesn't understand. And so you're still stuck in the same place. You've solved nothing. You've paid no technical debt down. I mean, you may have paid some of it down, but not enough, simply because you don't maybe work from some standard that your entire team is working on. And this can happen in like community settings where you have people contributing um, features, and they have sort of an understanding of the way they do it, or sometimes the core development team will have a way of understanding things the way they do it, and people in the community find it hard to actually use the code. And I've seen this in a number of cases where people want to contribute to a project, but the internal development team style is so sort of unconventional and just kind of amongst themselves that no one can understand what's going on. They can't understand the code, and they can't really, it's a barrier to contribution, and that would qualify as some technical debt in that project. Okay, so how do we sustainably deal with project complexity? This is a sort of a parallel question because remember I said a lot of technical debt will come from complexity. If you're adding complexity to your project, you're adding technical debt by definition. And if you already have technical debt in place, it just compounds that technical debt and it just, gets worse. So, we have to be able to sustainably deal with project complexity. And there, of course, is something called the software crisis, which is where, you have these big projects where people build software and you have to build these big software projects. And in doing so, you end up introducing a lot of complexity. And if that complexity is not well managed, then there's a crisis where you can't fix things, where sometimes the software is unfixable. And there are a lot of large software projects where that becomes a problem, where it's really hard to manage a lot of the things that you need to do. I can't think of any specific examples I want to pick on right now, but you'll see this term come up, software crisis. That there's this large amount, and oftentimes people talk about it in tandem with complexity. So if you have a large project, there's a lot of complexity. It's hard for a team to manage all that complexity and keep on top of everything that's changing, or all the problems that you might have. And you try to solve it with doing different types of methods and increasing your workforce, getting better tools, but it doesn't make a difference because underlying that is this sort of technical debt that you need to pay down, and sometimes you can't because your project is so complex. And then another part of software complexity is that you have things going on at different levels of the project. So software complexity can be kind of broken down into architecture complexity, web complexity, project complexity, component complexity, and program complexity. So we talked about program management being where people are managing projects being the smaller units where you have specific goals, programs being where you have these overarching goals. But that's just the human component, the human factor. You also have software architecture, and then components and the way it interacts with the web. We could have usability complexity in there too. Basically, software is, and this is a software centric thing I'm talking about here. You have all these different moving parts, and they're not all sort of compatible. Sometimes we don't stress usability, but we should be stressing usability because, as it turns out, that's a major component of our software. And if we don't spend a lot of time in usability, we gain an enormous amount of technical debt in that direction. And so, trying to think about usability, say, from the start, is better than thinking about it later, treating it as an afterthought. And this is true if you're really resource constrained. Sometimes projects are very resource constrained. So I think a smart strategy going in is to just pick one or two things to work on to specialize in. But the problem is that it doesn't matter because you have all these things you have to think about eventually. And if you don't think about them to start with, you already start accumulating this debt. So I have more graphics here that might be helpful in understanding technical debt. So in this case, this definition of technical debt is whenever software is developed in a partial way that later produces errors and artifacts that need to be addressed with a stable process and features. Again, this is what I was talking about when we can use usability as a case. If I skimp on usability at the beginning and I say, well, that's an afterthought, I don't care about that right now, I just want to get some things in place, that's fine. But sometimes you don't, you can't ignore usability. And if you're building a complex piece of software and then you say, okay, we're going to build an interface over it, that's fine. But sometimes the interface isn't very good. Sometimes the software isn't very good with respect to the interface and so forth. So, you have all these problems that arise simply because, and, sometimes you can't help it. Sometimes you're so resource constrained that you can't think about it right away. So that, and again, like I said, technical debt is not something you can solve. Sometimes it's not solvable, and it's hard for people to grasp that. When you do your assignment, I want you to remember that you can't win with technical debt. Sometimes you just have to have a manageable amount. So sometimes going in, you might ignore usability, but then you come back to it and you just accept that you have a lot of technical debt to overcome. So that, I mean, that's just a strategy people do in projects. And it's not that you're bad. It's not that you've done a bad job. It's just a fact of life. In other words, it's the result of prioritizing speedy delivery over perfect coding. So they see this as a matter of like a trade-off between doing things or promising things in a short amount of time versus trying to get things perfect. Like I said, you don't need to get things perfect, but if you're time constrained, then you can't really you can't really work on things. You can't really perfect them. You can't optimize them, I guess is a better way to put it. So if I have a very short amount of time to work on this, I have to just kind of work on it until I get to my deadline. And if it's good enough, I release it. And it's crap, has a lot of technical debt, and my reputation suffers. One way, to solve this, of course, is to make the project, to reduce the scope of the project and say maybe we'll only work on 2 or 3 features in the delivery time that we promised, and then really kind of, make it as good as possible. So there are a lot of ways to sort of manage your way through technical debt. You won't reduce it to zero, but you'll have it as manageable as possible. And so this article at the bottom of the slide talks about with great technology comes technical debt, talking about that very scenario. So again, this is where we have someone riding a unicycle who's going slowly, and that's where they have round wheels and they're able to move but slowly, versus this person with the square wheels is trying to pedal as fast as they can. And you see that neither of them have really made a lot of progress in their journey. So this is something to think about. um, but again, thinking about this in terms of these constraints, so debt can be incurred if it can be managed. So if we have, financial constraints or time constraints, or we have a large scope or a small scope, that's going to affect our quality. And all these things are kind of playing a role in technical debt. These constraint models, especially, because I think if you use those constraint models, you can understand from the beginning where your technical debt will lie, and then you can go and try to address the technical debt where it is. So that's, this is kind of one of the things I think one of the keys to sort of getting around technical debt as a barrier to your project. Another way to look at this is to use a dashboard. So some organizations will use a dashboard not to look at like productivity, but to look at their architecture, look at all the things that are going on in their project, all the moving parts, and to sort of assess technical debt in each of those. And so this dashboard monitors this quality speed trade off and then translates that into technical debt. So, in cases where there's high degrees of technical debt, those are actually where I guess it's, yeah, you go from low to high levels of technical debt. These are color coded. I think red is like high levels of technical debt, green or low levels of technical debt, and in between is like the orange or yellow. And then, this allows you to look at your project, look at the moving parts, see the places where there's high technical debt or suspected high technical debt, and then sending in resources to address them. Now, you have enough squares here so that you have enough moving parts. You can clearly see that there's some red areas, but it's not a majority of the project. There's certain hot spots in the project where, we can address those. So this kind of tool will help you, find where this is. And the constraints model I talked about earlier will help you understand kind of what's caught, what kinds of trade-offs are making to, make our project work, but also where the technical debt might lie. So like if our scope is too big and the quality suffers, we know that maybe we should rescope or descope the project to make it smaller, and then our quality might go up. And we can solve some of our technical debt through that, or we can see the components where, maybe we didn't spend enough time on developing one part of the project, or we didn't spend enough resources on something. We picked a platform that is not well maintained. If you're working off of open source projects, oftentimes this can be a problem because you pick an open source project and it might have a very good set of features, but it might not be well maintained. So when you start the project, that thing is great. And then over time, it becomes a problem because it's not being maintained. It's not being maintained to the standards of like modern code. So, like when Python went from 2.x to 3.x, there was a lot of software that had to be rewritten to reflect 3.x Python instead of 2.x Python. And some projects just aren't maintained well enough to have that happen. So that can be a significant source of technical debt. You also have cases where in open source projects, you can have, you know, projects basically people lose interest in them, or sometimes they can't keep up with the security issues that occur in the soft development of the software. So, evaluating like the different components of your project, I think that's a good strategy for at least keeping on top of technical debt. You're not going to get it to zero, but it'll be manageable. This is the Medium article that talks about this dashboard approach. Okay, so in this article here by VMware, they talk about technical debt as the price of change. And this is about housekeeping in open source. So this kind of addresses technical debt in the context of open source. And so this graph is very busy and it's hard to kind of understand at first glance. But basically, what they're trying to do is they're trying to think about technical debt as the cost of change, right? So the cost of change is if I adopt some solution and then I want to change it to something else, right? Or if I want to be responsive to things and I want to, basically, rewrite parts of my software or refactor the software. So there is a cost to change. It's not just that you can just make changes whenever you feel like it. Sometimes people get used to the software being a certain way, and then you change things and it's a problem. Other times it's investing in the resources that you need to change things. So, to refactor software costs labor, costs money sometimes. to maintain software, it costs money. If you want to build a community to do bug reporting, that will cost you in terms of building that community. If you want to hire professionals to, kind of do things in your project that make them better, that costs you money as well. So there's always a cost to change, whether it be like reputational or, kind of in terms of usability, or it might be in terms of finance, or it even might be in terms of project scope. Because your project scope might be such that it's not big enough to sustain large changes to things. So this graph, on the x-axis, we have time. So this is kind of our project unfolding over time. And then our y-axis has two components. So it's one of these graphs where you have two y-axes. The y-axis on the left is cost of change, which can range from low to high. So sometimes it costs you nothing to change something, right? If you want to change some of the documentation, if you want to update the documentation, or if you want to add to the documentation, there may be, a low cost to that. If you want to refactor the software, if you want to change from Python 2.x to Python 3.x, the cost of change is higher. And if you have to go and you have to rescope your project, the cost of change might be higher still. So the cost of change is everything in red. The responsiveness to change is on the right side, the right-hand y-axis, and that is in green. And that also ranges from low to high. So your organization, there's a cost to change, but also a responsiveness to change. Sometimes your organization is not responsive to change at all. Sometimes your organization, and especially like in large bureaucracy type corporations like IBM, or I guess maybe Microsoft is like that, or whatever. You have to get approval for changes. Sometimes you have, because your software is so complex, um, you can't really be responsive to change. Maybe the cost of change is very high, and so that affects your responsiveness to change. Maybe the organization is set up in a way that does not allow for, say, smaller teams within the larger team, within the program, to make changes on their own, sometimes for good reason. So the result of that is you have a low responsiveness to change, and the cost of change is high. So these two things are kind of linked, but they're important to think about separately as well. So we have this optimal cost of change, which is basically low over time. And then we have the actual cost of change. So the optimal cost of change is where you don't have to think about cost of everything is pretty cheap. The responsiveness to change and the cost of change are low. Everything is very easy to do. It's easy to respond to things, easy to implement changes. But in actuality, that's not how the cost of change works. In actuality, the cost of change goes up over time and, in fact, starts to become exponential over long periods of time. So if I don't change my version of Python, if I don't change from 2.x to 3.x, eventually there will be a Python 4.x, and then I have to go from 2.x to 4.x. And there's a huge difference in terms of the resources I need for that. Also, it's harder to respond to those changes because there's so many of them to make that it's really kind of that cost is really getting high now. So the difference or the delta between optimal cost of change and actual cost of change is this technical debt. So the way they think of technical debt is a lot more quantitative than the previous definitions. This is where we actually have a difference between the optimal cost of change, which would basically be around zero, and the actual cost of change, which it increases with time. So the longer we wait to make changes, the longer we wait to respond to our technical debt, the higher the cost is going to be. And it also requires a higher responsiveness to change, because if our organization doesn't allow for that, then we can't do it. I mean, if we have like 2 people on our team or 3 people on our team, we can't engage in a massive amount of refactoring. It just isn't going to be feasible. So, so that's technical debt and the way they define it. And then, of course, you can think of responsiveness in much the same way. The optimal responsiveness is close to the highest level of cost of change and the highest level of responsiveness to change that you can have. But that's, of course, different from the actual responsiveness, which falls off over time and, in fact, crashes to near zero at the end of this graph. So it's kind of like it slopes downward, and you get this basically situation where you can't respond to change at all if you have too much technical debt to overcome. And of course, we could take this blue arrow, this blue double headed arrow, and put this in between the optimal responsiveness and the actual responsiveness. And that might also describe technical debt. Okay. So there are different ways, and you can, and if you put numbers on this graph, if you were to quantify these things, you would have a nice sort of metric of technical debt. So you could say, this is our level of technical debt for this month, our level of technical debt for next month, and so on and so forth. Now, unfortunately, the real world doesn't afford us opportunities to make a nice, neat quantitative model like this. But this conceptual graph gives you an idea of how you might do this. So, there are a lot of things that go into this sort of, housekeeping in open source. You have things like backlogs of issues. You have things like accumulated unaddressed changes in software, and those can all be part of technical debt as well. So you could actually kind of quantify, um, the cost of change as how many issues you still need to solve, or how many unaddressed changes do we have in our software, which also links to these issues that we're creating. So these are the action items that I talked about earlier. If we have a lot of those to solve, our cost of change is higher, our responsiveness to change is lower because we have too many things to do in our backlog. But we also have a lot of unaddressed changes in our software we have to spend our time on first before we can move on to other things. So, we might solve this through refactoring. We might also solve it through automation. And I'm going to talk about automation later in the class and we're going to give a good treatment to automation and its roles in project management. But one way you can overcome technical debt, of course, is to implement automation. And of course, what's on everyone's lips right now is AI. We're using machine learning or something, as if that's like the way to solve this, which you can solve some of your problems, but you really shouldn't rely on anything like that because this can actually, automation can introduce more technical debt on top of everything else you're doing. If you implement it correctly, maybe you can solve some of your problems. But maybe it's not the same as refactoring. It does, if we think about automation as a potential solution to technical debt, if we think about it in terms of maybe improving responsiveness, it may improve responsiveness, but it also might create more problems than it solves. So, there's an article here at the bottom where they say, how much time should we spend on automation and refactoring? In general, something like GitHub is where we can use automation for good. We can use it to manage contributions across team members. We can use it to manage versions of things. Sometimes we implement automation that's bad, and sometimes it's a mixed bag. More often than not, it's a mixed bag. So we have to think of everything we add into our bag to try to solve technical debt. Sometimes introduces more technical debt, and it contributes to that complexity. So, there's a connection between technical debt accumulation in teams and productivity. And this is a graph that shows kind of how this works. So if we have high levels of technical debt, it may refer to something like a low code quality. So if your high technical debt as a result of low code quality, you might end up trying to fix that, but it's hard to fix because when you have high levels of technical debt, you also have low morale and motivation amongst your team. And if you have low morale and motivation, it ensures low code quality, or it can lead to low code quality. Low morale and motivation can also lead to lower productivity, but also low code quality can lead to lower productivity. So this can become a vicious cycle pretty quickly. Now, if you have lower productivity, of course, there's pressure to increase productivity. Naturally, when a manager sees that productivity is crashing, they want to increase productivity, and they try all these fixes, maybe not thinking about technical debt and maybe the high level of technical debt the team has. And so, in this pressure to increase productivity, you get even more technical debt because you have low morale, you have low quality, and you have low productivity, which is getting even lower because this is all kind of a vicious cycle. So you can see how this kind of gets out of hand. If you maintain high levels of technical debt, you can go through this. If you let technical debt accumulate, you can also go through this process. There are other strategies for kind of making waste visible, and so by doing so, you make technical debt visible. This is an article from scrum.org where they talk about how to do this. So, one way out of this loop is to kind of use these visualization tools. This is a case where you're not visualizing technical debt per se, but you're visualizing your processes and the waste in your processes and sort of suboptimality of your processes. So you can see in this case, in one here, in this figure on the right, you have the number of units versus the ideal timeline, and productivity goes down as time increases. So if you're working on like 3 or 4 features, the longer it takes, the lower your productivity. And then number two is number of units versus that ideal timeline. You get now the arrow in one, the straight line with the arrow is sort of theoretical productivity, but in number two we have this squiggly line where it's actual productivity. So it's the yellow line that kind of goes up and down. That's actual productivity. So productivity doesn't necessarily go down over time as a direct function of time. It kind of moves around depending on, technical debt and how you're working in your team. It depends on execution and how that actually happens. So you can actually make your waste visible by looking at idealized productivity versus actual productivity. And if there's a gap there, you can then visualize that gap. And like in the case of the dashboard, you can actually kind of diagnose where your technical debt is. The same thing can happen with the number of issues. So over time, as you get a greater number of issues that you have to solve, that can also contribute to differences in actual productivity versus desired productivity, and that delta, that difference, is the waste. And so we can kind of figure out where our technical debt is increasing over time. Maybe it's due to having too many issues. Maybe it's due to having too many units. Um, we can kind of figure that out with these visualizations. Then there's this article defining, measuring, and managing technical debt. This is from IEEE Software Magazine. This was in May and June of 2023, and this kind of discusses defining, measuring, and managing technical debt from the standpoint of developer productivity. Again, and they offer recommendations in this article, 5. The first recommendation is to have a technical debt management framework. You can use a dashboard, you can use other types of metrics, you can use other types of ways to detect it and to root it out. Sometimes you want to adopt something called a maturity model, which is where you kind of consider how your process evolves from something that's kind of, you're just implementing the best solution you can to something that becomes mature. So sometimes technologies, when you implement them, are not mature, or you just kind of implement the best strategy that you can, the good enough strategy, and then they mature over time. And in that maturation, you can get rid of the technical debt. There's number 3, proactive, strategic, and structural approaches. So if you can figure out a way to have a proactive strategy to managing technical debt that's best, it's usually a lot of monitoring of your team's activities, a lot of monitoring of the culture of the team, maybe the community, and monitoring kind of what you're doing and how you're doing it. So, there are a lot of ways you can do this and implement these kinds of approaches where you're keeping tabs on the technical debt. There's also instruction and continual engagement. So sometimes it's a matter of teaching your team, especially if you have an open source community or some external community, external to your or development team. instructing them on best practices or instructing them on what's expected of contributors versus like a core development team. If the core development team has a specific type of culture that they kind of follow, then it's best for the community to follow the same culture. And so that's number four. And then number five are developing metrics to characterize that which we went over just now. Now, this is a YouTube video, and I don't want you to watch this whole thing. In fact, you probably shouldn't watch any of it, but it's basically where this guy sits down, shares a screen, goes through this GitHub repository. It's this app called Food Not Food, and this app has been long suffering. It's been abandoned, and it needs to be cleaned up and refactored. And so he sits here for I think 3.5 hours and goes through kind of cleaning up this repository, basically refactoring it. And this is a good instruction of like how you can implement changes that will improve your level of technical debt. So we assume that this repository has a very high level of technical debt and that there are a lot of things to fix. So sometimes it's a matter of just really engaging with it for a long period of time and just kind of fixing all the things that are, where the debt is accumulated and try to work out the problems and get it in shape. Sometimes if open source projects get abandoned, they will do this where they kind of put together a strategy for refactoring or cleaning up everything that needs to be cleaned up. This is from the Linux Foundation. This is an article that was published during the pandemic on technical debt and open source development. So this is the link to this study, and it kind of discusses technical debt in open source organizations so that we have a better understanding of it and how we might mitigate it. And so what we've talked about so far is largely organizational responses to technical debt. So a lot of the metrics, a lot of the things that I mentioned, it's all like the organization is, kind of making investments, doing things a certain way. And then you get this technical debt that accumulates and you have to pay it down. And a lot of times organizations are stymied by how to do this. Sometimes you have these duct tape processes, which means they're just good enough processes that you kind of make small fixes to as you go along. This can be, like workflows or code, or maybe like, so like team building and things like that. And sometimes it's just simply a lack of coordination. So sometimes it's not really intentional. It's just a byproduct of, not having the perfect solution and not making adequate changes and adaptation to it. And sometimes it's just a lack of coordination, poor management, poor technical execution, whatever. But that's all organizational. So that's on the organization. But sometimes there are other types of technical debt that we incur in organizations that is sometimes intentional, sometimes it's necessary, and sometimes it is just kind of malicious or not good. So there are other types of technical debt. There's temporary technical debt, which is where debt accumulates as we get things integrated. So remember, we talked about the development strategies. We talked about the trunk versus branch strategies. And sometimes your team will work in GitHub and they'll work from a branch, like maybe 2 or 3 people on your team. They'll work on a branch and they'll be working on something there and it's not pushed to the main trunk yet, but they have like a significant component of the project there. So while that's being worked on a branch, it won't be visible to the rest of the team. So they're not privy to what's going on there. And that's technical debt because if they need to integrate with that, they can't do that until that branch gets pushed to the trunk, the main trunk. So sometimes you have to integrate things with the upstream branch or the trunk, and it's hard to kind of manage things in the interim. But that's all temporary because eventually that gets integrated. The problem though is managing or coordinating that so that other parts of the team aren't left hanging and they have to like wait for people to get their act together. Another type of technical debt is unknown, which is where we can't detect it, but it's there. Sometimes that's through bad practice, and we don't really have a metric for bad practice. So if people deviate from a workflow, that can lead to technical debt. Sometimes miscommunication, if I'm not straightforward about all the challenges I'm facing in my end of the project, if I'm giving an update and I say, I don't have any problems, and I do that for 2 weeks, but in fact, I have significant problems with some technical issue, and then it surfaces that I can't get it done because I have too many problems. That's bad communication on my part and kind of my fault, but it makes a problem for the whole team. There's also purposely created technical debt. So this is where you have unique forks that diverge from the rest of the project. So we're creating forks in our class, and we create a fork, we make a copy of the repository, we have it somewhere else. Sometimes we diverge from the original project. So a lot of times with these, we saw that Linux fork tree where you have many forks. And that actually is a good illustration of technical debt, where every time you make a fork, it diverges from the original thing. And then if you want to make everything, if you want to say issue a security update, you have to update every fork downstream. But if, sometimes people will accept those changes, sometimes they won't. So, when you make a fork, if you diverge too far from the original source, you can have technical debt just simply by being different from that forked source. And so a lot of times with projects that have a lot of forks, there will be technical debt that accumulates in that way. Sometimes people want that because they want to try out new things and then they get rid of that fork. Sometimes it's just kind of, you know, purposely created because you're forking it and then you have to kind of work with it later or solve it later. And then finally, you have obsolete things. So this is technical debt where you have standards or solutions that are no. So as technology moves on, your project has to move on. And if you can't move on because you've picked an obsolete standard or solution, then you have to kind of migrate to something else. So those are other things that we can't we haven't talked about yet, but are important. So again, an example of technical debt might be migrating a process, migrating from one part of this technology stack to another. So changing out AWS with another cloud server. You have things that happen in the world, such as when Unity changed their pricing scheme, or when Red Hat changed their licensing agreements, or when there's an end of product life. So there's an end of life notice on a product. Those are all things that can kind of force technical debt on an organization. This other thing called code smells is another way to kind of measure technical debt, but it's not quantitative. It's sort of a horse whisper type thing where you have, if you're like good in kind of, some people are good at this and some people aren't. So basically what you're doing is you go through a code base and you look at code, and there are characteristics of code that kind of give an sort of an intuition of a problem. So sometimes you see runtime exceptions or mysterious variable names or some sort of contrived complexity, like you use a lot of lines to do something you could do only in a few lines. And that's indicative of a larger problem. So sometimes you can look through code and you can just tell that this is a problem or this is going to be a problem. So people use code smells a lot. It's not quantitative, but it is sort of this sort of intuitive way to detect technical debt. And then one way around this, of course, or to solve this, is to do code refactoring, where you get some strong whiffs from the code, and then you say, okay, let's devote time to refactoring. So when refactoring, you rewrite the code in small controlled steps, and you can solve that problem. So there are different ways to address technical debt. Um, this is a YouTube video kind of describing why you should refactor your code. Why should you spend the resources refactoring code? Maybe you shouldn't always do it, but it's definitely something you should think about if you have this approach of kind of looking for code smells and evaluating productivity and things like that. So basically, this is sort of a summary of what we have. We have SAT engineers, and there's a pile of complexity, languages, tool chains, infrastructure lying between the engineers and the applications. And then, you might think, well, and so this pile of complexity represents technical debt, more or less. And so one solution you might think of is, well, let's automate things. Let's introduce AI. This will make non-engineers happy because they can acquire the skill set of an engineer and they can deal with this hidden pile of complexity or this technical debt and reach the end goal. And so what ends up happening is that you end up with a bunch of sad people because your automation solution adds a new pile of complexity or some new technical debt on top of the old technical debt, and it makes people increasingly sadder. And it stands as now two barriers to your application. So this is a case where you have technical debt. It doesn't make your team very happy or productive. You try to solve it, and with the best intentions, you create two piles of technical debt. So this is something that, like I said, you're never going to solve all of your technical debt, but there are deliberate strategies you can use to get around technical debt. So sometimes, we have to worry about scope creep as a form of technical debt. This is something, of course, like I said, you might your project might be too big to start with. You may have to refactor or rescope it down to a smaller size or descope it. So sometimes you work on a project and your scope eventually, gradually gets larger and larger. And this is something they call scope creep. And so this can impact project schedule, cost, and value. And this, of course, is an organizational form of technical debt. So, you want to be able to manage your scope. And a lot of times, this is something that we can monitor with this equation. This is something called earned value management or EVM. And this is where we can think about this in terms of our budget. So our scope should reflect our budget. And if we're spending more money, then we're probably going to be expanding our scope unintentionally. We may not realize it, but that's maybe what's happening. So we have the budgeted total cost minus the budgeted cost completed, and that should equal the actual cost of work completed. So that's the equation. And then, of course, we can look at the value and make an estimation of how much technical debt we might have or how much we're able to overcome it over time. So we take this earned value measurement at maybe 3-month intervals and we look at it over time. And so if we have some sort of value that's negative, much less than zero, it's an indirect indicator of technical debt. So basically, if our cost completed is larger than our total cost, I think that's the way it would. Then our actual work of cost completed would be negative, and we would have this technical debt. Basically, whatever that negative number is the amount of technical debt. But this is in terms of the budget that you have. So that's a direct indicator of that cost constraint. And then when the actual cost is equal to or greater than zero, then prioritization and estimate planning overcomes technical debt. So if you're increasing your number over time from a large negative value to a positive value, you've overcome your technical debt. So that's just one way you can look at scope, cost, and technical debt and kind of get a handle on it. So basically, we want to reduce friction from the start here. So we want to reduce community friction, we want to reduce team friction. And in the GitHub repo that you've forked, I have examples of technical debt. If you look in the technical debt directory, you'll see some examples of technical debt as they kind of occur in the wild. So it might be useful as well.